All right, welcome back to section 7. And in this section, we're going to look at API performance and advanced features. Now, up until now, we've looked at the basic concept of actually having to run an API, which includes the CRUD functionality, your create, your update, your retrieve, and your delete. We've looked at how to do all of those with Django REST framework. And then we utilize the generics views. However, with that, there's a little performance issue, and if not addressed, you might not notice it while starting, but once your platform begins to grow, scaling or performance becomes a problem or a challenge. So it's necessary we actually have to treat this. And by the end of this week or this section, the goal is to have your performance well optimized. We learn techniques to optimize database queries and prevent the N+1 query problem using select related and prefetch related. We're also going to handle pagination, where we master the art of breaking down large data sets into manageable chunks to improve API response and time, improving also the user experience. We're also going to look at filtering and searching, where we filter our responses based on some conditions, and also where we can do a semantic search across fields, some defined fields in the database. Then we're going to also add a way of throttling or API protection to our API endpoint. Let's get right into it. First, let's try to understand what is the N+1 query problem. You might wonder. Now, we're going to get practical here. First, when an application executes a separate database query for each result returned from an initial query, this is the N+1 problem. Now, let's look at our code. The previous example we did treat, where we had to return our post. Now, when you check the post model, you will notice that our post model has a relationship author to another model user. Because of this is a perfect example of an N+1 problem if not properly handled. Why is this? Because imagine we have 10 requests on our post model. Let's say we have 10 queries in our query set, 10 posts inside our model post. You might not notice this, but as soon as you start getting larger numbers, let's say you have 1,000, you have 10,000, that's when you notice very hectic performance issues. And how can we actually curtail this? We can solve this using the prefetch related or select related. Now, how this becomes an N+1 query problem is that when Django tries to access the data from the database, it makes the first query to retrieve all the posts in the database. Then after it has gotten all of the posts, that's the one, then the n number of times becomes the number of times it would have to query each of the posts to get the author of that post. Remember, this isn't a field directly within posts while having a relationship to another model, which is the user. So for each post in the database, it would have to make a separate query. So if we have 100 posts in the database, it will make 100 requests to the database to get the author. So it first lists all of the posts. It first grabs all of the posts within your database. Then for each of those posts, it undergoes an iterative process where it tries to grab all the author for the post. So if there are 1,000 posts, it makes 1,000 queries plus the one query to get the 1,000 posts. So you can imagine how largely inefficient this is. So this is a severe performance degradation. It increases database load, and even the application might crash under high traffic. So there must be a way, or there must be need to actually fix this. This is why it's called the silent API killer, because at the start, of course, there's no problem. You don't notice any problem. Your code runs, everything works. You feel like you're done with the code and all of that. But when the platform starts to grow, you realize that there are large performance issues on those platforms. So this is what we call the N+1 problem. Now to fix that, we introduce select related and prefetch related. So this makes Django, instead of making n number of queries for each relationships in a field to another model, what happens is that it makes a single query to get all of the posts in this example. After it has gotten all of the posts, the next thing it does is that it gets with select related, it makes this query similarly that it gets all of the author at the same time. So without executing multiple SQL queries. So because of this, we have just 2 queries done by Django just by using select related. It sounds so simple, but it's very well neglected, and that's the reason why platforms, when they start scaling, becomes an issue. So because of this, to achieve this, all we need to do, it's very simple. We just need to add select related, and then we select that author while we're fetching the posts. So let's have to add that there. You literally add this while we're fetching the post. You literally add this in your objects dot select related. So we're selecting all the authors relating to that particular post. So we're selecting the author relating to that particular post. Ensure that the field you're defining here is actually the exact same name you have as the field with the relationship in your database. So with this single little stuff, we've been able to prevent a heavy silent performance issue. Now you also have the prefetch related. We've already discussed the different kinds of relationships. We've talked about the foreign key relationship. We've talked about the one-to-one relationships. We've talked about the many-to-many relationships. Now, when you have, like in the example we looked at, we had post, and then author field in the post model has a direct foreign key relationship to the users. Now, in that case, you use select related. When you have one-to-one, let's say one post should be for one user. Let's assume that's the nature of your platform. It means that one-to-one should also use select related. But when you have, let's say you want to do a reverse relationship. Reverse relationship indicates that, for instance, in our post model, we have the author having a direct relationship to the user. Is that correct? Now, when you're in the user, when you're querying the user object and you need to get all of the posts under that user, it's called a reverse relationship. In this manner, you have author pointing directly to the user. So it means that many posts can be owned by one user. So when you're trying to avoid N+1 query problem there, you use your select related. However, when you're trying to access all of the posts of a user, you remember this is pointing to another model user. So when you're referring to another model, when you're referring to the post of this user from the user model, let's say you're querying the user model and then you want to get the post, all of the posts related to that user. What to use in that case is prefetch related. So this avoids n+1 problem. So while you use your prefetch related also in the many to many relationship. So with this, we get to have minimal queries for our post. You can imagine that as compared to having an iterative process. Imagine having a million posts. You have to run the query a million times. That's largely unproductive and will cause a very grave performance issue. So with this simple stuff I had just explained, we're able to solve our n+1 problem. So we're going to treat one other tool that's important for your API's performance. Now we're going to look at filtering and searching. So Django is so beautiful in that you don't have to do a lot of work. It's already doing a lot of work on the background for you. So when we want to do filtering, all we just have to do are some very basic configurations. And with that, we can have to filter our responses. We can have to search within specific fields semantically on our responses from the database. Now, first we'll try to attend to here is our filters. So we want to include filter, but to include filter we'll also utilize a third-party Django package called Django filters. So however, we will need to install this to our virtual environment. So this is, I'm going to install it. Remember what I told you, you would want to check out documentation pages of packages or libraries before you get to use them. Now this is PyPy, where Python packages are published. So on PyPy you can see pip install Django filter. Pip install Django filter. But when adding it to your installed app, you should add Django filters. Note the difference. That's why it's important to check out the documentations. So let's go ahead to install this. Pip install Django filter. Right. So let it install. It's done. So let's also add it to our requirements. Pip freeze requirements.txt such that it updates our dependencies. You can see Django filter 25.1. So with that, we've added it here. So we need to also, let's remember to put a comma here to avoid a mix-up. So we need to add also on our REST framework default filter backend. So add Django filters dot REST framework dot Django filter backend.